us, yeah, while we wait for, let's wait 1 more minute, and then we'll start. Can anybody figure out how to get to 24? Let me try. So 7 times 6 is 42, divided by 42 divided by 2 is 21. And then 21 plus 2 is 23. Okay, so I don't quite get there. I've used all the numbers, but I get short. I don't get to 24. Can anybody get to 24? Who's got the power? No. Okay. Anybody, any suggestions? I'll give you a hint if you need one. So my hint to you, my cryptic clue is, what happens if you add 7 plus 6? Who can get us to 24 if you add 7 plus 6? Welcome, Harry. Welcome, Suzanne or Susanna. Welcome, Maya. Azande. It's wonderful to have you guys here. We're just warming up. Jabulile, welcome to you. Can anybody get to maths 24? Can you get to the number 24 using these 4 numbers?
I'm just helping a student here with sound, so just excuse me for a bit. All right.
I'm going to start now because I think, again, it's good for us to start promptly, then students will get into that habit. So just to give you the answer to this, if I remember correctly, so 7 plus 6 is 13. Oh, I see someone here. 7, Kenneth, you're on the money. 7 plus 6 equals 20. Yeah, okay. Sneh, you're also on the money there. 13 times 2 is 26, and then 26 minus 2 is 24. Okay, so that is our warm-up done, and you'll see that I'm very fond of maths 24, and it's good just to get your brain moving. So just some basic rules, ideas. You'll notice that we do like our pictures on this in this class. So get yourself a nice space where you can sit and you have a pen in hand, like this guy or this girl, so that you're ready to actively learn. Put your cell phone or laptop on mute. I will definitely ask you to unmute. Probably I'm going to try for every 15 to 20 minutes, where I love to hear students' voices and get a sense of what they're thinking. But most of the time, if you have a question, we want you to use the chat, and Anya will be manning that and responding to your questions in real time in the chat as best she can. And then about every 15 or 20 minutes, I will ask for questions from the class or just comments, just so we get a bit of hiss in our class and we feel like we're connected in a class. Otherwise, if it's just text, it can feel a little bit like cyborgy. Okay, so let's get the show on the road. Oh, wait, I wanted to do one more thing before we did that. Just a reminder that the website for Watobe is really important. So in order to do, we do these fun quizzes on Wednesday. And in order to do that quiz, you need a login account with Watobe. And the way you get that is by going to the website. And in fact, if you want to get your Zoom link for the session, you also need to go to the website. So please make sure you spend some time, some quality time with the website. Okay, so that's it. Okay, so in the last lesson, let's actually go back to this. And in fact, before I even put it on the screen, you tell me what we were doing in the last lesson. I want some words to come up. So in the chat stream, get those fingers loose. What are some words that you remember from the last lesson? And where were we when we finished the last lesson? I'll put one word: brackets. We definitely spoke about brackets. What else did we speak about? It's been a while now. It was Wednesday last week. So go back into your brains and grab what you can. What do you remember? BODMAS. Yep. BODMAS is always applicable when dealing with stuff. Hi, David. no, it's good that you join us. Just try and get you at about 6 if you can. We actually open the classroom at 5 to 6, so you're quite welcome to come in from there. I remember the word equation, and I remember the word scale from last week, and I remember the words like recipe or operation. So these are basically, at the end of last week, we were learning how to solve equations, and we were dealing with equations with brackets and, you know, like basically variables on both sides. Excuse my squiggly writing. Today, there's going to be a bit more of a focus on equations with fractions and also what we call simultaneous equations. So that is kind of where we're going today. And we're going to start with just going to a short kind of warm up with basic equations with fractions. I'll make it nice and big. And I want you to see, can you solve these 5 basic equations, which all have fractions in them? So I know you'll say, okay, well, there's no X or variable, but the block is the variable. So what number has to go here? In fact, let me use my yellow. What number has to go here in order for this equation to be true? And we spoke about this last week too, this idea that equations, some values make equations true, some values make equations false. So for example, if I said that the square in A was definitely going to be 10, I can almost, that is definitely not true. That's just lying, or not, maybe not lying. I made that up. Okay, you've got 3 minutes to do this. And I want you to try and answer all 5 of these questions. Let the games begin, and then I will make some comments. Anya, how are we doing on size for the questions? Can you see them all right?
Yeah, that should be fine. Yeah, that's fine. You can leave it like that. I'm just helping a student here of sound on my side.
No problem.
If you guys have any technical issues, you can reach out to me in the chat. That's why I'm here.
Perfect. So guys, and also let me actually bring the chat up on my screen a little bit more so I can see. So guys, if you've got a problem with the size of the question, I can definitely do that. Felicia, I see your hand is up. Have a look at the chat box. You'll see that there. And the rest of us, you're doing, I'll do the first one with you. I'm going to use this technique. Let me zoom in a little bit. I'm going to multiply both sides by 6. Oh, no, that 6 is way too big. I'm going to multiply both sides by 6 because of the division by 6 at the bottom here. And one of the main things we learned last week was if you do the same thing to both sides of an equation, the equation stays true or it stays in balance. And I encourage you to have a look at previous videos if you're not sure about that, because it really does work. If you multiply both sides by 6, what you get on the one side is you're going to get essentially just the square by itself. And then on the other side, sometimes a useful trick is if you're multiplying by 6, 6 can be written as 6 over 1. It helps with knowing where the numbers go. And then I'm going to get 6 times 12, I know my times tables, so it's going to be 72 over 3, which is going to give me 24. Or some of you may have done this. You may have cancelled the 3 goes into 6 twice, and 12 times 2 is 24. Both answers give you the same thing. So I want you guys to finish off those next 4 for me as kind of a warm-up to equations, fractions and equations, and that sort of thing.
So while they calculate that, I'd just like to give a shout out to my paha. It's their first time with us today, so I hope they've got a wonderful evening with us.
Welcome. Yeah, welcome to Robin. I think that's, am I saying it right? Kedibona, I've seen that name before. Welcome. Tino Tenda, welcome to you. It is lovely. Sichle, welcome. Kelly Bogile. Felicia, who else is here? Zoom user, Zaniti, Chioma. It's wonderful to have you guys. Okay, I'll give you a little bit more time, and then we'll So I'm just going to do the second one here. So what do we have? So I'm going to multiply both sides by 5 in this one. And then I'm going to get 12 times 5 is 60, or 60 over 4. And that gives me 15. So that's that one. The answer here was 24. And then in this one, what am I going to do? It feels like this 2 is the problematic part. So what I'm going to do is I'm going to say, what's the opposite of dividing by 2? It's to multiply by 2. But I'm actually going to put this thing in a bracket just to, as an insurance policy, and multiply this by 2. If I do that, 2 over 2 is 1, and I get left with this big square here. And on this side, I get left with 2 times whatever 30 divided by 4 is. Now, I could write this in a different way if I wanted. I could write this as 2 times 30 over 4, which may make it easier for some people, not sure. But basically, if I write it like this, then I'm going to get 60 over 4, which is 15. Okay, and it's the last one here. The thing that is drawing my eye is this bit here. And what I would like to do is I would rewrite it so it's easier to read. Whenever I see these division things, I like to write them like that. It means the same thing, but it makes my brain a bit less sore. And if I now look at this question, actually, some of you may have other ways of doing this. Now that I look at it, I mean, some of you might say, well, 15 divided by 3 is 5, and I can just go from that stage. I'm just going to use the method I've been using so far, where I say, look, I multiply this side by 5, and I multiply this side by 5. I'll just emphasize where the 5s are. And then I get left with, what do I get? 5 times 15 over 3. 75 over 3, which I think is 25. And the good thing, guys, about equations is you can always check your answer. So what is 25 divided by 5? It's 5. What is 15 divided by 3? It's 5. And so both sides are happy. And then the last one, I'll do a little bit quicker. Let's do it probably the way some of you are doing it. 12 over 4 is 3. So I get that question. And now I'm going to multiply both sides by 3. And so I get, and I can check, 9 divided by 3 is 3, 12 divided by 4 is 3. Okay, so these are what we would call simple equations that have fractions in. Give me a thumbs up if you feel like, cool, I kind of get what the crazy math teacher was doing. Or if you're feeling like, oh, I'm not quite comfortable with this, give me a thumbs down. And then I can go from there. Okay, awesome. Moving swiftly along, guys. Well done. Okay, now example 10 is a little bit harder. I want you to try and use the logic that we've used so far. And I'm going to emphasize the fact that the thing that is making this question difficult, the thing that's making it a fraction, is this 3x plus 1. And I just want to give you 2 minutes to try and do it by yourself. Or not even 2 minutes, 1 minute. I just want to give you 1 minute, and I'm going to keep this 1 minute, and then I will come along and show you how to do it. But using the same ideas as we've shown above, how would you solve this equation? Remember, I want to know, in this case, what the x value is, that if I put it in here, it would make this true. Okay, give it a go. I have faith in you. You can do it. How do I deal with that 3x plus 1? I'm even going to type a message in the chat. If only I could get rid of the 3x plus 1 in a legal way. If only. Sorry, guys, if I could ask you to put onto mute, I can definitely hear somebody's younger brother or sister there, which is lovely in some ways, but I fear a distraction for the maths.
Yeah, so sorry to interrupt, Shame. I think it's just Felicia. She's struggling a bit of her sound, but I think she's got it right. Now, just let me know in the chat if you're managing or not. Just on my side, it's so good. I can see some of you guys are writing down your answers and working at desks. That's brilliant. Keep it up, guys.
Well done. Yeah. So one of the core ideas I spoke about in the first lesson was an equation is a lot like a scale. I know we don't think of it like that all the time, but essentially the one side is over here and this side over here is balanced. It's almost like these two bricks are in balance. But the problem now is if we're going to solve this, we have to get the x's, these little blocks here by themselves. And it's a bit of a mess on the left-hand side. So what I'm going to suggest is I really want to undo divided by 3x plus 1. And the opposite of dividing by 3x plus 1, in fact, you know what I do? I put a bracket around this thing that's dividing. It helps my brain know that this is one thing. And what I'm now going to do is I'm going to multiply this side by 3x plus 1. And a lot of students, when their fractions involved, they get a bit confused between what's the numerator and the denominator. So what I sometimes do is I put it all over 1, just to make my brain a little bit less sore. But now the problem is I've unbalanced the universe. The force is no longer happy with me. So now what I'm going to do is, in order to keep it equal, I'm going to multiply this side by 3x plus 1 over 1. Now, the good news is that when I have anything over itself, essentially this is equivalent to 1. And as long as it's being multiplied, which it is, these two are designed to knock each other out. They're inverse processes. And I get left, and this is the hard step, I get left with this. Now the question is exactly like something we did in the previous lesson. And I want to give you a chance to try and do that now. So I'll give you another sort of 30 seconds or so. Can you get to the answer from there?
David's got his hand up, sir.
Brilliant. Go ahead, David. What's your question?
Oh, sir, what I don't understand is how did the bracket 2x plus 1 cancel 3x plus 1? I don't get it. How did it cancel?
Yeah. So David, are we hanging out in this part of the world over here where the big yellow thing is? Is that what we're talking about?
Yes, sir.
Okay. So basically what I'm doing is, at the beginning, I recognized that the 3x plus 1 was the problem. And so I literally, if you think about dividing by something, if I take 5 divided by, how do I do this? 5 over 4 equals, let's say, 10 over 8. You would agree that that's true because I just doubled, I basically doubled the top and bottom. I've multiplied by 2. Now, this statement, okay, if I wanted to get rid of this 4 over here, what's the opposite of divide by 4? It's going to be times by 4. So if I do that, if I multiply this by 4 on this side, it's no longer going to be equal to each other. I have to multiply this side by 4. Now, would you agree with me that 4 divided by 4 is 1? So,
yes, sir.
And so now if you think about it, if you look at this little equation I made up, this equation is still true because 4 times 10 is 40. 40 over 8 is still 5. So all I was doing is I was multiplying by the denominator that was down here, and I was doing it to both sides so that I could get rid of the 3x plus 1. And you'll see that it magically appears on this side. We're going to do some more, David. So watch this pattern. This idea is going to be repeated a couple of times tonight. And I understand why you're still feeling a bit confused. And so I'm just going to ask you to watch the next question as well. Okay, so now what we need to do is this is the last lesson in case you're unfamiliar. We have to distribute this 2 into the bracket. And so what we're going to do is we're going to go 2 times 3x is 6x, and 2 times 1 is 2. And so now we've got rid of the bracket. So in order of difficulty, fractions are definitely the hardest. Brackets are next. Now we have terms, variable terms on both sides that we have to deal with. And what I'm going to do is I'm going to add x to both sides. And if I add x to both sides, I'm going to end up with this. And ask yourself what happened. Minus x plus x is nothing. 6x plus x is 7x. And now I'm going to take away 2 from both sides. And I get that. And so now the only thing making life difficult is this, and 0 divided by 7 is 0. So the answer for this question is 0. Okay. So I know sometimes people get a bit worried about that. But actually, there's no problem here because there's no division by 0 in the denominator. 3 times 0 is nothing, plus 1. Let's do another. Actually, that's a little bit hard. Let me find. Let's see if we can find one that's a little bit. Okay, let's give this a go. Okay. I want some ideas from you guys. If I say to you, we have to solve this equation. This equation is quite a bit harder than the last one. And I think what makes it hard is this part here. It's the fact that there are 2 denominators. And now suddenly, I don't just have to get rid of one denominator like the previous question. I have to get rid of 2. And I want to know maybe if somebody could tell me, if you put your hand up and we can let you talk, or in the chat, how do we handle an equation that has 2 lots of fractions? David, I see your hand. You want to give us a suggestion?
Sir, and this thing's not going to cross multiply or something like that.
Yeah, you're on the right track, David. Exactly. So this idea of multiplying. What I often like to think about, although, is I think I find basically a common multiple of denominators. This is sound a bit weird, but like, if I make something special, I'm going to say, I'm going to multiply both sides of this equation by b plus 3 times, or not b plus 8, it'll be b minus 8. So stop for a moment and think, why am I choosing to construct something like that? Why am I choosing it's actually basically a lowest common multiple of these 2, yeah. I'm looking at these 2 and I'm saying, look, I really want to eliminate them from my life. And so essentially what I'm doing is cross multiplying, but I want to be consistent in my approach and show you that really what I'm doing is I'm multiplying this side by b plus 3, b minus 8. And on this side, I'm also going to multiply it by b plus 3, b minus 8. Now my b's look a bit like 6s, so apologies for that. But if you look at this question, it started out with 2 things being equal. If I multiply both sides by the same thing, it's still got to be equal. And this is where the next step comes along that's so clever. Can you see that I now have a b plus 3 at the top here and a b plus 3 at the bottom here? Can you see I have a b minus 8 here and a b minus 8 there? I haven't done this just by mistake. I've done this deliberately because by multiplying by this rather strange looking thing, I'm going to eliminate the b minus 8 on this side, and I'm going to eliminate the b plus 3 on that side. And so now I go to the cleanup phase, and I go b minus 8 times b plus 9. And then on the other side, I have b minus 1 times B plus 3. So I would like some questions or comments from the class, because I know that that was quite a big jump. And I want you to just stay here for a little bit, because if we get it, it will be really, really helpful to you. So why did I choose to make up this rather strange thing to multiply both sides by, which was this? And the reason was, it was designed to get rid of the denominators that were there. Notice how my life is now a lot simpler because there are no more fractions around. There are just brackets. Now, for those of you who feel comfortable, I want you to try and finish this question. Can you solve this question? And the key to it is going to be to multiplying out these brackets. But remember, you need to do all 4 pairs. Okay, so I'm going to give you a little bit of time to multiply this out and try and solve. And then I will give you a similar question to go with that on top of that. Now, I know I'm making your brains hurt tonight. I do realize that. So if you are feeling overwhelmed, please do make a comment in the chat and I will slow right down. Dave, do I mean the distributive law? Yes, David, that is exactly what it's called when you distribute the one bracket over the other bracket. So the question is, what is the answer going to be? Remember that we've gone on this merry journey, but how do we actually, the goal here was to find the value of B that made the original statement true. Okay, welcome in Bali. I see an Evelyn, welcome to you. Welcome to Nizole and Harry and Morendi.
I think we're very quiet, sir.
I think I've dropped the mic and everyone's still scrambling to pick it up. Okay, so we're going to do another one like this now. So if you're feeling overwhelmed, don't run away quite yet. I know it's the end of the day, but let's just go through this process now. B times B is B squared. B times 9 is 9B. Minus 8 times B is minus 8B. Minus 8 times 9 is 72. So that's the one side. Then the other side is...
Sorry,
B,
sir.
yeah?
Negative 8 times 9. Should it not be negative 72?
You are on the money. Fantastic. That's what teamwork's all about. Thanks. So 3B, okay, wait, B squared plus 3B minus B minus 3. And now it's the cleanup phase. Now here's the good news, guys. When you ever see two of the same things on the opposite sides of the equation, they knock each other out. Basically, if you subtracted B squared from both sides, they would disappear. So good night, B squareds. Then what is 9B minus 8B? It's just going to be B minus 72. And then on this side, in order to do cleanup, so I did a bit of cleanup here. What's the cleanup going to be here? It's just going to be minus B minus, oh, wait. It's going to be 2B minus 3. And then the last bit now is I am going to have to deal with these B's on opposite sides. I think the easiest way to do that is going to be take away B from both sides. So I'll get minus 72 equals B minus 3. Make sure I'm not doing too fast here. And then I'm going to add 3 to both sides. And I get minus 69 is B. And I do think I saw that answer somewhere in the chat. So what? You on the money, guys. Well done. That was a tough question, to be honest. Okay. I want to do a quick brain break just to get your brains free, because I know they would have been working hard now. So I want you to find a space in your room. You can still see the camera, and I want you to grab a pen. And I want you to hold the pen at the very bottom, and we're going to do something called a pen flip. And what this does is it forces your brain to just leave maths alone for a couple of seconds and focus on something else so your brain has a chance to breathe. Okay. So the goal now is to flip the pen in the air so that you hold it at the bottom and it rotates and you catch it at the same point at which you flipped it. Okay, so I don't know if I can do this, but let's see. So hopefully you can see my camera. So I'm holding it at the bottom. Ah, I did it. Hope the camera got that. We'll try again. So flip. Oh, I couldn't do it this time. So you basically flip the pen in the air, or that was 2 rotations, and you try and catch it where you started, and then just have a quick stand up and try and do it standing so that you give your body a break from sitting, because we've been going for half an hour already, and I think you need a break before we continue. If you can manage to do it, I want you to post a happy face. So a happy face in the chat means I know that you've had one successful pen flip. I'll see if I can do it now. Let's see. Oh, almost. Oh, that wasn't bad. Okay. I will watch to see if there are any happy faces who have mastered the pen flip. When I teach in class, my students love that. I don't know if it translates as well online, but I always enjoy just standing up. It's hard though, huh? It's like it takes quite a bit of fine muscle control. Felicia, go ahead. What is your question? It's a great time for questions while we're just having a break. You can come online. You can unmute yourself. I'll take your question straight.
Felicia, we're struggling to hear you. Make sure you speak up into your microphone.
Oh, so Felicia, is it about the topic we're covering tonight? If it isn't about the topic tonight is equations, mainly equations with fractions and simultaneous equations if we get there. Okay. So if it's not related strictly to that, I'm afraid tonight we're not going to deal with it, but we can talk about it maybe another time. Okay, guys, I hope that I won't say that you're refreshed, but I think that you would feel a bit better than we did when we finished the last question. So I want you to try, and again, I know that I'm pushing you tonight. I do realize that. I want you to try and answer. I mean, these are properly hard questions. After this one, we're going to move on from fraction questions. But I want you to think about this. Let me actually just scan my other question. Maybe I'll see if there's another one we can do that's it's the same sort of question. Okay, yeah, let's just do this one to finish with. I know that equations with fractions do make students feel a bit uncomfortable generally, but I believe that if I teach you the method consistently and I model this the correct way over and over again, you will get it. It's just like practice. You know, it's like if you're trying to do a sit-up or a press-up, you just have to keep going. So I'm going to say, please solve this equation for me. The hint I'm going to give you is that you need to deal with this divided by 3, okay? But whenever you do something to an equation, whenever you do something to modify it, you always need to do it consistently to both sides. And I want to give you just a minute to try and complete step 1. Once I've done step 1 for you, you'll be able to find it a lot easier. But I want to give you 60 seconds, a minute to try and see how would you start this question. And then I'll take on from there. Okay, so give it your best shot. How would you begin to solve this equation? And the key word would be solve for A. So in your exam, it would say solve for A. So Felicia, unfortunately at this stage, we don't have maths lit lessons. Maybe in future, but for now, Watobe offers lessons from grade 7 to grade 12. And we offer lessons on basically 2 days a week. And then sometimes they do additional intensive modules during the year, but they specifically advertise for that.
I just want to say from my side, I'm just watching, obviously, the kiddos can't see each other, but we as hosts can see the videos. And I'm so proud of all you students working so hard. I'm really proud of you guys. Keep it up.
Yeah, these questions definitely take a lot of, things got real now today. Okay, here's the technique I would use. And I know that there are quicker ways to do this, but I'm doing it a way that's consistent, that I know that it'll always work. I'm going to multiply this side of the equation by 3, and I'm also going to multiply this side of the equation by 3. And for those of you who are like, oh, there's fractions, does the 3 go to the top or the bottom? Sometimes it's even nice to write it as 3/1. Okay, now I've done this because there's the potential to make a very silly error here if you don't take out some insurance. In this question, this part over here has a fraction, this part over here has a fraction, but this bit over here is kind of without a fraction. And knowing how that gets dealt with is really what makes this question hard or not hard. So if I assume I'm going to multiply both sides by 3, I now need to distribute this 3. And so I multiply 3 by the first thing, and multiplying by 3 undoes the dividing by 3, and I'm just left with 2a minus 3. But then I need to multiply this 3 by minus 3a, and I get minus 9a. Now on this side, if I multiply, basically I know that there's only one term. It was divided by 3 already, and now it's going to be times by 3, I get left with a. And so this whole question can be simplified to a much nicer looking equation like this. Now, I know a lot of you wouldn't have got that, but let's see, can you take it from this stage to solve the equation now? Okay, let's have a look here. So if I clean things up, I'm going to clean up this first, and I get minus 7a minus 3 equals a. If I add 7a to both sides, I get a plus 7a. So then I get minus 3 equals 8a. And then I have to divide both sides by, basically, now this 8 in front is stopping me from solving the equation. And so I divide by 8 here. And anything over itself is 1. And so a is minus 3/8. And I could check my answer if I want, but I know that that is correct. Is 3 over minus 8 the same as minus 3/8? It is indeed. It is exactly, so basically, if you write minus 3/8, or if you write minus 3, oh wait, let's just put plus 3 over minus 8, or if you just put the minus in front, because a negative divided by a positive is a negative, it actually, all of those would be correct. Okay. Okay, guys, what I'm going to do is I think I'm going to leave equations with fractions for the moment, and we're just going to touch on one other. Let's just see if we can squeeze. How much are we going to squeeze in? Okay, I'm going to squeeze in this word sum things another time. I just want to talk to you about simultaneous equations. So for the last bit of this lesson, just give me a sense of how you guys are feeling. Thumbs up if you're feeling, look, I mean, tonight's lesson has been tough, but I feel like I'm learning. Give me a thumbs down if you're feeling like, oh, you know what, man, I'm feeling overwhelmed and it's hard to feel motivated. Let me just see the thumbs up or thumbs down. Okay. Yeah, because I don't want to, one of the challenges being a teacher online is getting to know your students and getting a sense of, normally you would have their facial cues or their body language, but I think we're doing an okay job so far. All right. Now, if I had to ask you, let's do this. If I say to you, solve this equation, and we spoke about this previously. Let's even just focus on one of these equations. Let's focus on the equation x plus y equals -1. If I say to you, solve that, we have a little bit of a problem because I need two numbers that when I add together, they give me -1. So I could say -4 plus 3 gives me -1. Or, and in that case, x would be -4 and y would be 3. But I could also say that x could be -6 plus 5, and that gives me -1. And so then we could also have, it could also be true that x is -6 and y is 5. So when I say solve an equation like x plus y is -1, it can't really be solved in the same way that our previous question could, where there's only one right answer. If I say to you, solve the equation x plus y equals -1, there are actually infinitely many combinations that could satisfy that. However, if I say to you, solve this question or solve this equation and this equation simultaneously, then I'm looking for a pair of numbers, x and y, that not only satisfy the one equation or make it true, they make both equations true at the same time. So let's see, what was one of the ones I said? I said in the previous question, I basically said, x could have been -6 and y could have been +5, and then it would satisfy this first equation. Will that satisfy this equation over here if I sub it in? Well, let's check. If I say y, if I sub it in here, 5 minus 2 times -6, that's going to be equal to 5 plus 12, and 5 plus 12 is not equal to 3. So we have a problem. We need a method or a process. I can't just go along guessing here. I need to find a pair of x and y's that satisfy both of these equations at the same time. And I'm going to teach you that method now. Maybe you've seen it, maybe you haven't, but this is what I do. These are both called linear equations because the variables have powers of 1. If you look here, there's powers of 1. And I'm even going to zoom in to make it a little bit easier to see. So what I do is I look at the equation and I work with one of them. Normally I work with the one that looks easiest to me. So right now, the easiest one to me looks like this one. The less easy one over here looks like this one. And I'm going to use a method called substitution. Now, guys, my spelling is not great because the spell checks have ruined me, but I think I've nailed substitution. Look at all those T's. What you do is you work with one of the equations to start with, and you are going to substitute it into the other one. Now, in order for the substitution to be meaningful, so let's write this down. So step 1, find the easier equation. Step 2, isolate a variable. Now, isolate a variable means just to get a variable by itself. And so if I'm working with the yellow one, I can isolate the variable by taking, or basically adding 2x to both sides. So if I do that, I'm going to get 2x plus 3 equals y. Take a moment to think about that. So first of all, I highlighted in yellow the equation that looked simpler to me. Some of you may say it's the other way around. It's not a problem. And then in order to get the y by itself, I actually added 2x to both sides. And what happened then was this minus 2x went away, and I got a plus 2x on that side. All I was doing was, yeah.
Sorry, I just see there's a few hands up. I know you're busy explaining, but I just want to reiterate here. If some of you guys find the first equation to be easier, you can also change the first equation. If you want to change it, for instance, to x equals -1 minus y, you can do that as well, as long as you change one equation. Sorry, back to you, sir.
No, exactly right. So you could deal with either of these two. I've just chosen the y because it caught my attention. But you know what? Now that I look at it again, part of me thinks actually maybe the one on top might be the easier one. Let's have a show of hands. If you like the first one is the easier one, give me a thumbs up. If you think the second one is easier, give me a thumbs down, and we'll go with the majority. So thumbs up if you like the first equation, thumbs down if you like the second equation. Okay. Okay, so I'm going to stay with the second equation just because so far. So what did I say? I added 2x to both sides and I got 3 plus 2x equals y. And what this is just the same equation written in a slightly different way. It's an equivalent equation. I've just done the same thing to both sides. Now, I'm going to take this equation that has been isolated and I'm going to, I'll put step 3, sub into other equation. So let's have a look at the other equation. And I'm going to leave a big open space where there's a y. You may say, why am I doing that? Well, I know that y is equal to 3 plus 2x from the one I started with. If I take that relationship and I sub it into the first one, it's going to look a bit like this. Let's see if I can do this. Oh, that's too big. Let's just change the thickness on that. There we go. So let's try that again. 3 plus 2x. Now, what you'll notice is when I do that, there are no more y's in my life. I have essentially eliminated the variable y by subbing in. So let's ask ourselves next, what happens? What have we got left? I know there's a bracket here, but there's essentially a 1 outside, so it doesn't really matter. And I get left with x plus 3 plus 2x is minus 1. I'm going to do this whole one for you guys, just so, because I know it's new. I'm then going to do some cleanup. I'm going to say that 3x plus 3 is minus 1. And then I'm going to say, if I focus on taking away 3 from both sides, I'm going to get 3x equals minus 4. And then if I divide both sides by 3, I should get x equals minus 4 over 3. So now the question is, have I found, now as long as I haven't made a silly mistake, which is always possible because I'm feeling a bit tired now, but x plus 2x is 3x, no, that's all good. How do I get y? Because remember, I had to find x and y. I wonder if anybody can give me a suggestion for this. How am I going to find y and use the x that I've got already? I know that x is minus 4 over 3, but now I want to find a y value that gives me the pair of values that makes it true. So I know this is a little bit tricky, and we'll do more of these in the next lesson, I promise. So if you're feeling unsure, but basically at the very beginning, we isolated a variable. So if I go where my blue pen is now, I'm drawing a huge blue border. We know that y equals 3 plus 2x. So let's use that. I'm going to zoom in and I'm just going to clear everything away so that it's not y equals 3 plus 2x. Let's just make sure I've got that right, that there's been no silly mistakes. 3 plus 2x. Yes. Okay. And we know we have a value for x. The value for x is going to be minus 4 over 3. Now, guys, we can actually use our calculators here if, I'm doing it manually because, I'm kind of doing it live for you, but you can just put into your calculator. In fact, I've got my calculator here. If you want, 3 plus 2 times minus 4 over 3. And what that's going to give you, it's just going to give you that. And then let me actually even just put that in 3 plus, I should get 1/3. And so my pair of numbers that solves this equation is going to be minus 4 over 3 and y equals 1/3. Now, we're running out of time tonight. We will stay on for a little bit, but basically that combination, if we try it out in the original equations, it will solve the equations, both equations simultaneously. Now, because of the fact that, I'm not going to go through it now because of time, but I just want to suggest that that is the method that we're going to follow. That's too hard. Let me make one up for you. And we're going to finish with this. So let me make up a simultaneous equation for you. That is, you know what, actually, let's take questions. We will start the next lesson with simultaneous equations. I don't want to actually push too much into a lesson. I feel like your brains are going to take too much stress. I'm just going to take questions now from the class, or comments, or things you want me to know as I prepare for the next lesson. And you can do that in the chat, or you can have your questions audibly. And then, just to get you ready, we'll have a little poll at the end as well. So, but are there any questions or comments or things you'd like to know? Yeah.
I'm just, while you're busy taking questions, I know Chioma's asked me a question. I'm just helping her in the box as well. But if anyone else has a question, just raise your hand and I'll give the microphone to you.
Also, I'm just going to outline what I think is a good way to do these. Let me just get that. What method we follow, because there's a very definitive set of steps, and all you have to do is learn how to follow those steps, and then it'll be easier. For now, it'll feel a bit hard. Any questions? So what are those steps? You need to isolate, or basically choose an equation. So choose one that's easier to work with. Then you isolate a variable. Then you sub the one equation into the other. And then you solve it. And then step 5 would be sub answer into original. And I will go through this process in the next lesson, so please do not be discouraged. Any other questions? Okay. How are you meant to write the answer is the question. So there's different ways of writing it. If they say write it as a coordinate pair, then you would write it like this. If they say solve for x and y, you would just write it like that. Okay. So what I want you to do, when are we having quizzes? David, we have quizzes on Wednesday. But what I'm going to do now is I'm going to end the lesson, and I just want you to let the simultaneous equation idea percolate in your brains for a bit. We're going to talk more about it on a Wednesday, and we're also going to talk a little bit about something called a quadratic equation. And you're going to ask you just to release the poll to students. I think we always want to get a sense of if we're meeting the needs of the students. And so if you could just fill in that little feedback poll, that would be awesome. And yeah, it's been fun teaching you today. Thank you so much for being diligent and attending. And yeah, if we feel like, we'll use the feedback to inform lessons going forward. Okay.
So Nazol is just asking, can you just go back to those steps you have of solving an equation, the one you wrote in blue, please?
No problem. Let's go back to that. So let me get rid of the, I'm sorry, the poll is cluttering up my, there we go. Okay, Nizole, whereabouts, which step are you talking about? So are you talking about when I was up on the left-hand side? Or are you talking about when I got down to like the lower right-hand side?
I think Nazole hasn't unmuted herself. I think she's just referring to step 1, find your easy equation. Step 2, do this. Step 2, do that. Because I know you've got it there. And then there's also a page where you wrote it in blue.
Yeah, let's point it out. So at the very beginning, we chose to work with the one that's highlighted, the yellow one. And when we worked with it, we decided below, we changed it into an equivalent equation, which is 3 plus 2x is y. And then what we did is we took the other equation. I know it's getting cluttered now, so apologies for this. But we took this equation up here and we subbed the one in blue into that. And so what we did was we said, look, this equation is just x plus something equals minus 1. That something is y. Let's put this blue thing into that. And so that's why over here I've got x plus 3 plus 2x is minus 1. Now, once I've got that equation, which is over here, I then have to neaten it up a little bit and use my equation solving skills. Okay. And that's where I went through these steps over here. And I got to the place where I got x is minus 4 over 3, which is great. But I've only then got one answer and I need a value for x and y. So then what I did was I went back to this original blue equation up here. And I said, we know that y equals 3 plus 2x, but I now have a value for x that I can use. And that's when I moved to this step down here. And I said, well, what's the value of x that we've got now? So what we've got is we know x is minus 4 over 3. And so I sub in